All right, this is pre-calculus notes 3.1. Determine if an equation defines y as a function of x. Okay, so in the previous video we said that if there is more than one output for each input, the relation is not a function. So our question now is algebraically, is it possible that you have more than one y for each x? And these rules are going to help you determine that very easily. Make sure you have these rules in your notes. But here's what it boils down to. For polynomials, if you have to take a root to solve for y, and if the root is even, then there are two solutions. One of them being positive, the other being negative. And so that's important because if you have y as your output and y has more than one solution, positive and negative, then the relation is not a function. So that's all this really boils down to. Make sure you have that previous page in your notes. Here is a first question. Does the equation define y as a function of x? What I'm going to do is I want to get y all by itself. So I'm going to solve for y. I'm going to get y all by itself. First, I'm going to add 32x and subtract 11. I'm going to divide by 2. And then I'm going to take the cubic root. Okay, so here's what I need to know. I'm taking an odd root here. And according to the rules on the previous page, if the root is odd, then there's only one real answer. If the answer is positive, the y would be positive. If the stuff under the radical is positive, y would be positive. If the stuff under the radical is negative, y would be negative. But I'm getting ahead of myself. The bottom line is that there's only one answer because the root is odd. Okay, 3 is an odd number. And so therefore, the answer to the question here is does the equation define y as a function of x? Yes, y is a function of x. All right, next problem. All right, write down the rule in this box. If the exponent of y is even, then y is not a function. If the exponent of y is odd, then y is a function. So in the previous slide, I solved for y, but with a little bit of insight, when I solve for y, I'm going to be taking a root as the last step. Is it an even root? Is it an odd root? Or maybe if the exponent is 1, of y is 1, then it's not a root at all. But if the exponent is even, then I'd have to take an even root to solve for it, and therefore an even root is not a function. But an odd root is a function. So all I have to do here is look at the exponent on y. The exponent of y is 2. It's an even number. And so therefore, no, y does not define, is Is the equation to find y as a function of x? No, y is not a function of x. I guess that's it. Hold on. Is there another problem there? Oh, okay, here we go. Here's some more problems. So now that we've got our rules down, these problems are very, very easy. We're only looking for the exponent of y. If the exponent of y is odd, then the answer is yes. If the exponent of y is even, then the answer is no. So here, problem 1. I've got an imaginary 1 there. 1 is an odd number. So yes, y defines y. Why am I getting tongue-tied here? The equation defines y as a function of x. Yes. Problem number 2 is no, because the exponent of y is even. Problem number 3 is yes, because the exponent of y is odd. Problem number 4 is no, because the exponent of y is even. That's it. It's as simple as that, folks. Okay.